Hello everyone, here we have the example for the topic differentiation. So consider the parametric equation for the curve where we have x is equals to cos to the power of 3 theta and y is equals to sine to the power of 3 theta, where the range is in between 0 until 2 pi. Find the first derivative and express your answer in terms of theta. So now given the situation where we have x is equals to cos theta bracket q, and we have next y is equals to sine theta q. So now I'm going to focus on the left hand side where we have x is equals to cos theta to the power of 3. So kindly differentiate the situation with respect to theta. So where we will have dx d theta is equals to 3 bracket cos theta square. Differentiate the internal function and we will obtain differentiate cos and we will have negative sine theta. Differentiate the theta and we will have 1. Kindly simplify the situation. Dx d theta is equals to negative 3 cos square theta multiplied with sine theta. Next, focus on the y. Differentiate the y with respect to theta and we will have dy d theta is equals to 3 bracket sine theta square. Differentiate the sine and we will obtain cos theta. Differentiate the theta and we will have 1. Kindly rewrite the situation. So dy d theta is equals to 3 sine squared theta multiplied with cos theta. Kindly refers to the question dy dx. So where we have the formula dy dx is equals to dy d theta multiply with d theta dx. So kindly substitute the situation and we will have 3 sine squared theta cos theta. So observe the situation where we have d theta dx. So where in the blue in color we have dx d theta, so meaning that we need to flip the situation. So it will become negative 3 cos squared theta sine theta. So finally simplify. So where we have dy dx is equals to, if we simplify the situation and we will have 1. If we simplify the situation and we will have 1. If we simplify the situation and we will have 1. So finally dy dx is equals to negative sine theta over cos theta. So at the end dy dx is equals to negative tangent theta. Kindly refers to the question B. Find the value of dy dx if x is equals to square root of 2 over 4. So meaning that now we are looking for the value dy dx. So given the situation we have dx d theta equals to negative 3 cos square theta multiplied with sine theta, followed by dy d theta is equals to 3 multiplied with sine squared theta multiplied with cos theta, and finally we have dy dx is equals to negative tangent theta. So now given the situation where we have x is equals to square root of 2 over 4, by referring to the situation, so we need to substitute the situation into x. So where we will have square root of 2 over 4 is equals to cos theta bracket q. So simplify the situation and we will have cos theta is equals to cube root of square root of 2 over 4. So if we simplify the situation, and we will have cos theta is equals to 1 over square root of 2. Number 1. Cos positive. So meaning that in here we have the first quadrant and the fourth quadrant. Second step is to find the basic angle. So where we have cos theta is equals to 1 over square root of 2. So theta will be equals to 45 degree with the basic angle. Step number 3, we have to determine the range. So in here, the range is 0 until 360 degree, where the 0 and 360 degree is not included. Step number 4, the rotation. So kindly refers to the basic angle, where we have to locate the angle at the first and the fourth quadrant. Then kindly refers to step number 3. Start from 0 until 360 degree, where 0 and 360 is not included. So step number 5 is the solution. So kindly refers to the situation. So here we will have the solution, meaning that the intersection between the basic angle and the rotation. So the answer would be theta is equals to 45 degree and 315 degree. Kindly express the answer in the form of radian. So we will have pi over 4 and 7 pi over 4 radian. So next what we have to do is to find the value for the first derivative, and we need to substitute the theta, pi over 4 and 7 pi over 4. So kindly refers to the question. dy dx is equals to negative tangent theta. So meaning that in here, when theta is equals to pi over 4, dy dx will be equals to negative tangent bracket pi over 4. So if we simplify the situation, we will have dy dx is equals to negative 1. Next, if we substitute the value, theta equals to 7 pi over 4, so the dy dx will be equals to negative tangent bracket 7 pi over 4. So finally we will have dy dx is equals to 1. So now kindly refers to the question C. Show that the second derivative is equals to 1 over 3 cos to the power 4 theta multiplied with sine theta. Hence, calculate the value for the second derivative at theta is equals to pi over 3. So, given the information from the A and B, we have the dx d theta equals to negative 3 cos square theta sine square theta. Next, dy d theta is equals to 3 sine square theta multiplied with cos theta. And finally, we have dy dx, or the first derivative, is equals to negative tangent theta. So first, in order to find the second derivative for the parametric situation, we need to write down the formula. So where we have the second derivative is equals to differentiate the dy dx with respect to theta multiply with d theta dx. So first, kindly follow the instruction where we have the second derivative is equals to differentiate the negative tangent theta then followed by multiply with the d theta dx. So where we will have 1 over negative 3 cos squared theta multiply with sine theta. So now, by referring to the situation where we have the second derivative is equals to differentiate the negative tangent theta. As we all know, if we differentiate tangent theta, and we will obtain second squared theta. So meaning that in here we will have negative second squared theta. Do remember to differentiate the theta, and we will obtain 1. So next, multiply with 1 over negative 3 cos squared theta multiply with sine theta. So meaning that in here we will have over negative 3 cos squared theta multiply with sine theta. So based on the trigo ratio, second theta actually is equals to 1 over cos theta. So rewrite the situation. So where we have the second derivative is equals to, if we simplify the situation, and we will obtain 1. Then 1 over cos squared theta multiply with 3 cos squared theta sine theta. So finally, for the second derivative, we will obtain 1 over 3. As we can see, cos squared theta multiply with cos squared theta, and we will obtain cos to the power 4 theta multiply with sine theta. By referring to the question, we have already shown the situation. Next is to calculate the value for the second derivative when the theta is pi over 3. So now, by substituting the situation, so theta is equals to pi over 3. So meaning that for the second derivative, we will have 1 over 3 multiply with cos pi over 3 bracket power 4 sine bracket pi over 3. So we will obtain the second derivative is equals to 1 over 3 cos pi over 3, which is equals to cos 60. So meaning that we will obtain 1 over 2 to the power of 4. As for sine pi over 3, where we have sine 60 is equals to square root of 3 over 2. So kindly simplify the situation, and we will obtain 1 over 3 multiply with 1 over 16 multiply with square root of 3 over 2. So if we simplify the situation, and we will have 1 over 3 square root of 3 over 32. Simplify the situation, 32 over 3 square root of 3. Multiply with the conjugate in order to rationalize the situation. So we will have 32 square root of 3 over 9. So where we will have the value for the second derivative when the theta is equals to pi over 3. So here we are, and thanks for watching.